Have you ever wondered how an air conditioner works? It's not just a simple cooling box. Welcome to the world of air conditioning, an invention that's more than 100 years old, and yet continues to be a marvel of modern engineering. It's our refuge from the sweltering heat, our oasis in the middle of a scorching summer. But how does this magical machine transform hot, uncomfortable air into a cool, refreshing breeze? Well, that's precisely what we're here to explore. We'll delve into the basic principles of air conditioning, unraveling the mysteries of the compressor, scroll compressor, condenser, expansion valve, and evaporator. We'll dissect these components and understand their individual roles in the cooling process. By the end of this journey, you'll have a newfound appreciation for this everyday appliance that's so much more than just a cooling box. Now let's dive into the fascinating world of air conditioning. The basic principle of air conditioning is pretty straightforward. It's essentially about moving heat from one place to another. Imagine a bustling room filled with people generating warmth. The air conditioner's job is to take that warmth and move it elsewhere, making the room cooler in the process. It does this by using a special fluid called a refrigerant, which has a low boiling point. This refrigerant absorbs the heat from the room as it evaporates, transforming from a liquid to a gas. This gas, now carrying the heat, is then transported outside the room, to a warmer place. Here the refrigerant is compressed, causing it to release the heat it had absorbed earlier, and cool down. Once cooled, the refrigerant condenses back into a liquid, ready to absorb more heat, and the cycle starts all over again. This process involves several components, each playing a vital role. Let's explore them. The heart of an air conditioner is the compressor. Now let's dive into the essential role of the compressor. Just like our heart pumps blood around our body, the compressor pumps refrigerant through the air conditioning system. And much like our heart, the compressor is a vital component. Without it, the entire system would fail to function. So what exactly does the compressor do? Well, it's in the name, it compresses. But it's not just about squishing something into a smaller space. In the case of an air conditioner, the compressor compresses the refrigerant, a special fluid that can easily change from a gas to a liquid and back again. As the compressor compresses the refrigerant, two important things happen. First, the refrigerant becomes a high-pressure gas. It's similar to inflating a balloon. As you pump more air into it, the pressure inside the balloon increases. Second, this process raises the refrigerant's temperature. Imagine rubbing your hands together quickly. They heat up due to the pressure and friction, right? The same principle applies here. You might be wondering why we'd want to make something hot in a system that's supposed to cool us down. Well, it's all part of the process. The hot, high-pressure refrigerant is essential for the next steps in the cooling cycle. The compressor's operation is fundamental to the air conditioning process. It sets the stage for the refrigerant's journey through the rest of the system. The refrigerant, now a hot, high-pressure gas, is ready to move on to the next component, the condenser. Remember, the compressor is the heart of the air conditioning system. It's the driving force that keeps the refrigerant moving, changing its state, and thereby enabling the system to cool down our homes, cars, and workplaces. It's a remarkable piece of engineering, and understanding its function brings us one step closer to comprehending the marvel that is air conditioning. This hot, high-pressure gas then moves on to the next component, the condenser. The condenser is where the real magic happens. This cooling component of the air conditioning system is a vital player in the process of cooling down your space. It's a bit like a hot potato game, but instead of a potato, it's the hot refrigerant gas passing through the condenser. Here's the trick. The condenser cools down this hot gas, transforming it into a liquid. This is possible due to the design of the condenser, which is essentially a heat exchanger. It's designed to dissipate heat, much like the radiator in your car. As the hot gas enters the condenser, the fan blows air over the coils, carrying away the heat and cooling the gas. This process transforms the gas into a high-pressure liquid. It's a simple yet ingenious process that makes our air conditioning systems work so efficiently. The liquid refrigerant is then ready to move on to the expansion valve. Now we come to the expansion valve, a key player in the cooling process. The expansion valve, also known as the throttling device, is a crucial component of the air conditioner. Its main job is to reduce the pressure of the liquid refrigerant that comes from the condenser. But why does it do that? And how does this pressure drop contribute to the cooling process? Let's dive into it. Firstly, think of the refrigerant as a team player that carries heat from inside your room to the outside. After the refrigerant picks up heat from the evaporator, it gets compressed in the compressor, increasing its temperature and pressure. It then moves to the condenser where it loses some of its heat, but it's still under high pressure. Here's where the expansion valve steps in. The high-pressure liquid refrigerant enters the valve and is forced through a small opening. This abrupt drop in pressure causes the refrigerant to cool down significantly. Remember, it's this cooled refrigerant that will absorb the heat from your room in the evaporator, thus making your room cooler. Now, how does the pressure drop cause the refrigerant to cool down? It's based on the principle of thermodynamics. When the pressure of a gas or liquid drops, its temperature also drops. This is because the molecules of the refrigerant slow down and their kinetic energy decreases, leading to a decrease in temperature. The expansion valve, in essence, is the gatekeeper of the refrigeration cycle. It carefully controls the amount of refrigerant that enters the evaporator. If too much refrigerant is allowed in, it can lead to inefficiencies and potential damage. If too little is allowed, the cooling effect will not be sufficient. So it's safe to say that the expansion valve is not just a valve, but a precision instrument, playing a pivotal role in the cooling process. It's the unsung hero of your air conditioner, working quietly in the background to keep you cool and comfortable. This cold liquid refrigerant is now ready for the final component, the evaporator. Finally, we reach the evaporator, where the cool air you feel comes from. It's the last essential component in our air conditioning journey, but by no means the least. The evaporator plays a crucial role in making your indoor environment comfortable. So, let's delve into what the evaporator does. In simple terms, the evaporator's primary function is to evaporate the cold liquid refrigerant back into a gas. This process occurs within the evaporator coil, an intricate network of tubes filled with refrigerant. These coils are typically located around your air handler's airflow, where it can do its job most effectively. But the evaporator's job doesn't stop there. As the refrigerant evaporates, it absorbs a substantial amount of heat from the surrounding air. This is the heart of the cooling process. The heat is effectively lifted from the air inside your home and transferred to the refrigerant. It's a bit like how when you step out of a pool on a hot day, the water on your skin evaporates, leaving you feeling cool. This is the same principle at work in the evaporator. The result? The air that blows out of your vents is considerably cooler than when it went in. The evaporator, through the process of evaporation and heat exchange, has cooled the air down. And the beauty of it all is that this process continues in a cycle, ensuring a constant supply of cool air. And what about the refrigerant? Well, it leaves the evaporator as a low-pressure gas, ready to be sucked back into the compressor. This is the start of the cycle anew, a continuous loop that keeps your indoor environment at a comfortable temperature, regardless of the heat outside. So, there you have it. The evaporator, with its simple yet effective function, is a vital part of the air conditioning system. It is the component that directly impacts the temperature of the air you feel, turning hot, uncomfortable air into a refreshing breeze. And that, in a nutshell, is how an air conditioner works. So to recap, the air conditioner works by moving heat from inside to outside. It all starts with the basic principle of air conditioning, which is the transfer of heat from one place to another. The compressor, the heart of the system, pressurizes the refrigerant, turning it into a hot, high-pressure gas. This gas then moves to the condenser, where it loses its heat to the atmosphere and turns into a cooler, high-pressure liquid. The expansion valve steps in next, relieving the pressure from this liquid, turning it into a cold, low-pressure mist. Finally, the evaporator comes into play. Here, the cold refrigerant absorbs heat from the room, cooling the air, and the cycle begins anew. It's a beautifully orchestrated symphony of heat transfer, pressure changes, and transformation from gas to liquid and back. Next time you enjoy a cool breeze from an air conditioner, you'll know exactly how that refreshing air comes about. Thanks for watching.